Okay, here's problem 5.10 from Stallings. And basically this comes in several parts. Part A says that let's assume a transmitted power of 50 watts. And we want to express the 50 watts in dBm and dBW. Straightforward calculation gives me 47 dBm. And in dBW it's 30 dBs different from that, 30 dB less, and it's 17 dBW. Okay, so 47 dBm. Notice that 50 watts is just 1/2 of 100 watts, and 100 watts is 50 dBm, because 100 watts is 10 to the 5th milliwatts, so we have 50. And 3 dB below that is half, and that's the 50 watts. So you can do this problem, you can do part A in your head, in fact. In part B it says, let's let the frequency be 900 megahertz, use a gain of 1, and have a free space distance of 100 meters, and we want to calculate the received power. Let's see, the received power, I calculate the loss of the air channel first, using the equation that has the 32.44 dB in it, which means the frequency must be in megahertz and the distance must be in kilometers. Plug in the 900 megahertz and the 0.1 kilometer, which is 100 meters. Plug those two values in, you get -70. You get 71.5 dB of loss. And now we're going to plug that into this equation, where I'm not including any gain terms because a gain of 1 is 0 dB of gain. And so my received power is simply my transmitted minus the loss. Simple calculation, minus 24 dBm. And it turns into 3.9 milliwatts. For part C, it says to go ahead and let the distance be 10 kilometers now. And here I recalculate the loss based on 10 kilometers. And when I do that, let's see, I have the 32.44, the 20 log 900 stays the same, that's 59.1, but now I have 20 log of 10 rather than 20 log of 0.1, and log of 10 is 10, log of 10 is 1, and so I have 20 times 1, or just 20 here. And so my new loss calculation is 111 dB. And so the received power is the transmitted minus the 111 minus 64.5 dBm. Finally, for part D, it says, now let's let the gain be equal to 2 with the 10 kilometer distance. And if the gain is 2 as a ratio, notice there are no dB units on the 2. It just says G equals 2. That means it's 3 dB. And so a very simple calculation, you can do it in your head, says that the received power is going to be 3 dB higher than the case where we had unity gain, which was part C. So from minus 64.5, you raise it 3 dB and you get minus 61.5. And so that's how you do problem 10. Hope that helps.